So here is my project. This is I'm doing an NLP classification pipeline using the Wellfig dataset. It is an aggregate of four existing databases: Kaggle, Magatir, Reuters, BuzzFeed, Political. It contains 72,134 articles. To a computational limit, I am only using about half of that, which is 35,000 rows. Let me see. So one thing I changed was in the data set, the labels are for the target. So 0 indicates fake news and 1 indicates real news. I flipped that just to keep um, just to align with my project convention. All right. And in terms of imbalance, there is virtually none. It's a 51-49 split. Uh, Contains 18,004 real news articles and about 17,000 fake articles. All right, and so this is kind of my process here. I First, for the data cleaning, I lower case everything, remove all non-alphabetic no, yeah, characters out of there. I tokenize all the texts and I remove all the stop words and um, do lemmatization on them as well. A text blob is used to create a sentiment score, which is a supplementary feature. And then for the vectorization, I use TF-IDF. And here I am only keeping 5,000 of the most important features converted during that process. And then I use a random forest classifier with 200 estimators. Okay, during my EDA, I found 22 missing rows, which were removed, which resulted in having only 34,978 rows. And for the training and test split is an 80-20 split. And my results were pretty nice. I got its 92% overall accuracy score. And for both target classes, I was able to yield an F1 score of 92.92. And when I cross-validated across five folds, I was also able to produce a mean F1 score of 92.92 and a small standard deviation, which is telling me that my model overall is stable and generalizing well on the data. So here is the EDA. Looks like I'm missing 100, missing 558 rows in the title and text, and I'm also carrying over index, which I'll drop later. Um, Here I'm looking at my data types. Again, int64, which I'm going to drop later. The label is int64. Title and text are string variables. And again, I talked about the flipping to align with my project standards here with the labels. Here is the sampling portion, taking only about 35,000 rows. Okay, I stratified the labels to make sure that they are even split, at least split with, and then here are the 22 missing rows. Just gonna drop them. And so here, right here, I take a look at just, the first couple rows here. So one really big thing here is that some of these articles contained a Russian articles, which pretty much means that during the process of converting them to numeric representation, these are going to go to zero because there's no way to map them. And so, yeah, I mean, I'm not too worried about that. And so you're looking at the distribution along my classes, pretty well balanced. And here I'm looking, I created a graph. Um, so what this is basically telling me is that uh, real news articles tend to have a higher word count than fake news articles. And so they're both right skewed or left skewed, sorry, left skewed. Uh, Overall, they kind of have the same general shape. And if we look more over here, the real newspapers again tend to be of a higher count, but these are outliers. Yeah, and the outliers aren't really going to matter too much because how random forest model processes those things. But yeah, let's move on. And so here is the distribution. I'm sorry, I skipped a step here. Sentimentality. Um, where did that go? No, I'm not gonna worry too much about that. So when I create a vector representing the polarity of the tone of each articles. And so here we can see that there isn't really much of a difference between the two because they kind of both have normal distribution going on over here. And which is mainly hard to make it distinguished between the classes. And if we look at the standard deviation and the mean here for real news tend to be more variable in their use of tone. And so negative tone, and then positive tone. And also something to really note that is that real news also are at two ends of the spectrum and they have higher range than fake news as well. Okay, so let's move on. So during the text processing again, convert everything to lowercase, remove all non-alphabetic characters, such as the, semicolon, the dash dash, things like that. Um, Tokenization, splitting everything into its own um, character in the vector. And here I removed all the stop words. So the stop words are there's a little nuance in here. When I ran it the first time, I found that rotors had the highest effect on the training for the model, and I realized that routers is a news source, so I had to effectively remove all the news sources that I can think of in the during the cleaning process. And so this was kind of causing it to underfit. Uh, and so, yeah. And so, of course, we removed the A is of words like such like that as well. And the lemmatization, this process just ensures that words like running, run, ran are the same words and so we don't have more noise in our data and they are treated the same essentially during the training process. And so yeah. And so just to loop back on the characters of those Russian characters. And so once again, since I didn't remove them at all and I just left them in there, the TF, IDF, when trying to convert those to numeric variables, the numeric representation. Since you can't map it to anything, it just contributes nothing to the training. So it has the value of zero. Um, and also another thing that I came across was the metadata. It's just the HTTP, .com, words like that. I didn't also remove, but we'll talk about that later. And so those aren't my biggest concerns, at least during this run. But yeah, that's something to note. And so here, after cleaning, so before everything here is, capitalized, yada, yada, yada. And here is the clean version. So you can see is, did, at, words like that were removed. And so, yeah. And then clean all the empty text. Um, so here is so just looking at everything again. Here's the sentiment score that was added. So these, again, just to note back, these supplement scores, since there's such a heavy overlap between the two classes, um, they are pretty much just going to cancel each other out. But I just left them there just in case maybe it might pick up a signal. But overall, if I were to remove it during testing, and again, I don't think this would have much of an impact on the overall outcome. And so once again, here it is. As a sentimental score, these Russian characters are pretty much a sentiment score of pretty much zero, less than zero. Um, so just look at the sentimental scores here. Yeah, means pretty much very tightly together. Um, Standard deviation is higher than the mean for real news, again, which means that it has more generally more it's more spectrum of tone than it does fake news. Okay, so training split. I am converting just using the clean text, the sentiment, splitting a 80-20 split in a random state 4, and I also stratify the labels as well, just to ensure that the class is balanced between testing and training data. Okay, so there we go. My training samples, testing samples, and just to circle back on my abstract here, I turn everything into numeric representation using the TF-IDF, and I'm only keeping 5,000 of the most important features. So vocabulary size 5,000. My matrix shape here. This is my training set and how many rows, and this is columns, right? Yeah. And here I just combine the sentiment columns in with the my TF IDF column. And so that's just one more added feature dimension. And here I set up my random forest model, training on X and training on Y, which again, these are these guys. This is the uh, combined data set there. And I'm using an N estimator of 200, meaning it's just going to create 200 distinct trees. And I set RAM state to 42. Yep, there you go. estimated 200 has has 5,001 features. So when I evaluate the model, here is my outcome here. So for real news, it had a precision of 93%, recall of 92, and F1 score of 92. Fake news did overall just 92, and with an accuracy score of 92. And so I like these numbers. It's not overly high and it's not overly low. It's a good starting point, really, for if I was to redo this testing again. It just means that my model is doing a really good job at generalizing and learning from the data. And so when I did a five-fold cross-validation, Uh, my results here, I have a mean F1 score of 92 and a low standard deviation. So since there's no gap between the F1 scores here, in my testing and my validation, and the standard deviation is small, I'm really happy with these results. My model's stable and it's generalizing very well. So here I created 10 graphs here, representation of my trees. So this is just 10 out of the 200 distinct trees that it created. I'm not gonna go through all of them, just gonna look at this one here. And so when it looks at lawmaker, it's saying, well, okay, if the threshold is less than or equal to, this number here is going to go here. And what I'm noticing on the left side here is that words like seams, spokeswomen, and images have little to no effect on decreasing the impurity. Um, and so, which means that it's just going to keep branching off and branching off until um, the impurity is zero, right? But if we look on the right-hand side here, ton decreased the impurity by about 0.16% here. And when we look at, but when the threshold didn't meet that right here, the impurity virtually becomes zero. And so that's something to look for. And then when we did in again on the left-hand side of this side of this tree here, um, child fact, no, pretty much no effect on that impurity at all, decreasing that impurity. And in fact, opposition increased it when looking at real data, trying to data there, real fact, real news. But yeah, real interesting stuff. Another thing I kind of had a hard time wrapping my head around was this value right there. Um, I couldn't figure out why it was bigger than the sample. Then kind of looking more into it, it's due to bootstrapping. So Bootstrap just kind of resamples the data. And so, which at first I thought it would cause it to be biased towards a certain class, as it does the resampling. But as I look more into it, it turns out that even though bootstrapping does cause certain biases in a specific tree, when they average out and vote a majority, those biases cancel out at the end. And so, yeah, so if we take a look at something like the ton here, when it's greater when it's greater than this particular number. So it found that it was, all fake. Found three samples, which are fake, but it used 11. And so which means that it resampled that 8 more times. And that's as if I'm understanding that correctly, but yeah. And so we'll move on. So here are the important features here. Said had the highest mean decrease in impurity. So which means that yeah, said had the most effect on or on the model's decision between fake or real news. Then followed by via image featured, and this kind of draws us back again to what I was saying earlier. These are metadata, and Getty.com, I believe feature was one of them, HTTP, even though HTTP.com, I mean, com and Getty had didn't have much an effect at all. Via an image did. And if I were to remove them, at least for this particular data set, I think that would cause it to kind of the accuracy in the F1 score to go down. But it would make the model a little more well-rounded when looking at news sources that are specifically text-based and have no metadata in it. But that's such something to make a mental note of. Okay, yeah. Here's this table. Yeah, and so yeah, so TF-IDF had a really good effective um, influence on the data by vectorizing and by turning them into numeric um, representation. So, which basically means so TF uh, basically looks at one particular document and says, hey, well, how many times these particular words appear in this one document? And then IDF looks at the same word and says, hey, how frequent is this word across all the documents given, right? So something like said had a really high importance score here. Was just saying like in if it let's say it's a real news article, said appears more frequently in real news sources versus when looking at all the documents, and maybe said and doesn't appear as often in fake news sources versus a a real news source. So which gives it a very high score, right? And so yeah. And so yep, I talked about the metadata here, which could be for now for this particular project, since they have such a large effect, I'm not going to remove them, but maybe during another time I would retest that. Okay, not going to worry too much about that. The random forest, and so here are kind of the limitations. Again, I'm only using due to computational limitation, only use about 30, about half of that, as well as keeping the metadata tags and keeping the Russian language articles, which only kind of add noise to the data, but there wasn't really a lot of them. So I didn't bother, removing them. So in the future, what I would kind of do different is use the whole data set, but instead of used going row by row and processing them using lemmatization and text blob, or use something like a multi-processing module to make them do it via parallel, which will speed up that pre-processing and really reduce the runtime. And of course, remove the metadata as well as since they're coming from different news sources during the split and test data, it becomes a little hard for the model to distinguish between articles from different news sources, meaning one news source can appear more often in the testing or the training data, uh, which makes the data look, I mean, which makes the model having a harder time to predict on finding new unseen data sources. And so, yeah, pretty much gonna in a later testing in the future, I would kind of like control that a little bit better. But yep, that's it. This is my project. Yo.